Hello everyone. In this video, we will be extracting information given an exponential equation. We remember that the graphing form of an exponential equation is y equals ab raised to the power x minus h plus k. Looking at this example that we have right here, we are given the equation y equals 3 parentheses 1.5 raised to the power x minus 4. Our 3 here is the A, 1.5 is the B, our H here is 0, and our K is negative 4. Now let's go over these questions that we have here. Is the given exponential equation, so this one right here, an exponential growth or an exponential decay? We remember that if b is greater than 1, then the equation is an exponential growth. If b is greater than 0 but less than 1, it is an exponential decay. So looking at this equation that we have here, since our b is 1.5 and it's greater than 1, therefore we can go ahead and say that this is an example of an exponential growth. So I'm just going to go ahead and put this inside the box. This equation that we have here is an exponential growth. You will see on the side the graph of this equation, y equals 3 parentheses 1.5 raised to the power x minus 4. As you can see, the graph resembles that of an exponential growth. Now let's move on to the next question right here. Describe the value of y from left to right. We remember that for exponential growth, the y value increases from left to right, or pretty much the graph is increasing from left to right. And for exponential decay, the y value decreases from left to right, or pretty much the graph is decreasing. So since this is an exponential growth, we can go ahead and say that the y value increases from left to right. So I'm just going to go ahead and write that down here. On the side, you will see the graph of this equation, and you can see that the value of y increases from left to right. And so that's what we have here as an answer to the second question right here. Now let's move on to the third question that we have here. What is the equation of the asymptote? We remember that the equation for the asymptote of an exponential function is y equals k. So in this problem right here, the equation for the asymptote would be y equals, again, remember our k is negative 4, so y is equal to negative 4. On the side, you will see the graph of this equation, y equals 3 parentheses 1.5 raised to the power x minus 4, and its asymptote y is equal to negative 4. What does this tell about the graph of the function? So we remember that this graph that we have right here, or this curve or exponential graph, is approaching or is getting closer and closer to this line, y is equal to negative 4, but it will never touch it. So this means that this is the asymptote, and this graph, y equals 3 parentheses 1.5 raised to the power x minus 4, gets closer and closer to this line, but will never touch it. So that is what we write down here. Okay, you will see on the side the graph of, again, this exponential function and this asymptote. Although it looks like the graph is touching the asymptote, y is equals to negative 4, but it is not. If we zoom it in, it's not gonna touch it. It just gets closer and closer to it, but will never touch it. Now let's move on to the next question right here. What is the y-intercept of the graph? We remember that in order that we can determine the x-intercept, we set y is equal to 0 and solve for x. And in order that we can determine the y-intercept, we set x equals 0 and solve for y. Since we're looking for the y-intercept, it means that we are going to set x equals to 0 and solve for y. So looking at this equation that we have right there, so I'm just going to go ahead and write it down here. So that's y equals 3 parentheses 1.5 raised to the power x minus 4. So we're going to set the x equals to 0. So this comes out y equals 3, 1.5 raised to the power 0. And then that is minus 4. Anything raised to the power 0 is 1. So then we go ahead and write y equals 3 times 1 minus 4. 3 times 1 minus 4 is negative 1. So then we can go ahead and say that the y-intercept for this, whenever x is 0, the value of y is negative 1. This means that this is the y-intercept. It's going to cross the y-axis at this point. You will see on the side the graph again of this y equals 3 parentheses 1.5 raised to the power x minus 4. You can see that the graph is crossing the y-axis at this point, 0, negative 1. We also remember that if A is positive, the graph is above the asymptote. And if A is negative, the graph is below the asymptote. Since our A here is 3 and it is positive, therefore we can go ahead and say that this exponential graph is going to sit above the asymptote. And you can also see that on the graph that I included on the side, this graph is actually sitting on top of the asymptote. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we are given this equation right here. We remember that in this equation, our A is 4, our B is 0.75, our H is 0, and our K is positive 3. Now, let's look at the first question here. Is the given exponential equation an exponential growth or an exponential decay? Again, we remember that if B is greater than 1, then it is an exponential growth. If B is greater than 0 but less than 1, it's an exponential decay. Since our value here is 0.75, it is greater than 0 but less than 1. This is an example of an exponential decay. So I'm just going to go ahead and put this inside the box. You can see on the side the graph of this function. Again, the graph that you see on the side resembles that of an exponential decay. Now let's move on to the second question. Describe the value of y from left to right. We remember that for exponential growth, the y value increases from left to right. And for exponential decay, the y value decreases from left to right. So in this case right here, the y value from left to right is decreasing. So I'm just going to go ahead and write it down here. On the side, you will see the graph and the value of y as we go from left to right. The value is decreasing. It started from a high value of y and then it goes down and down as we go through the graph from left to right. Now let's move on to the third question here. What is the equation of the asymptote? We remember that the equation for the asymptote for exponential function is y is equal to k. Since our k here is 3, we can therefore say that the equation for the asymptote is y equals 3. You will see on the side the graph of this exponential function and its asymptote y is equal to 3 in broken line. Now let's move on to the next question. What does this tell about the graph of the function? This tells us that this graph is approaching towards the line or the asymptote, which is the line y is equal to 3. So we can go ahead and write that down here. Okay, you can see on the side that if we trace the graph, it gets closer and closer to y equals 3, but again, it will never touch it. Although in the picture, it looks like it's touching it, but if we zoom it in, it's not going to touch it. Now, let's move on to the fourth question here. What is the y-intercept of the graph? We remember that to determine the x-intercept, we set y is equal to 0 and solve for x. And to determine the y-intercept, we set x equals to 0 and solve for y. Since we wanted the y-intercept, again, we are going to set x equals to 0 and solve for y. So I'm just going to show the work down here. Okay, so the y-intercept is 0, 7. On the side, you will see the graph of this function. You can see that the graph is crossing the y-axis at 0, 7. So this is our y-intercept, or this is the y-intercept of the graph. Now, we also remember that if A is positive, the graph is above the asymptote. And if A is negative, the graph is below the asymptote. Since our A here is positive, we can say that the graph is above the asymptote. And you can see that on the side, the graph is above the line y is equal to 3, which is the asymptote. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!